In the previous video, I defined supremum and infimum of a set. We can also talk about the supremum and the infimum of a function, which is what I will define in this video. When we say something like the supremum of a function, what we actually mean is the supremum of its range. Or more specifically, if I talk about the supremum of the function f on a certain domain I, what I do is first I construct the range. Here is the range defined using set building notation, and this is a set. And since that's a set, we know how to try to calculate its supremum. So the supremum of the function is the supremum of its range. Here is another notation you will encounter that means the same thing. For example, I have defined a function here via its graph, and I want to calculate the supremum of this function on the interval from -2 to 2, including both endpoints. So what I do is first I figure out what the range is, and the range is the interval from -1 to 1, both endpoints included. So the supremum of the function on this domain is the supremum of its range, which is exactly 1. I have defined here supremum of a function, but we do the same thing to define other concepts such as upper bound, or maximum, or infimum, or minimum. Here is an example. I have defined a function g via this graph. The domain is the interval from 0 to 2, including both endpoints. This function is certainly bounded, both above and below. If I try to calculate the maximum, I can't. There is no maximum. If I look at the range includes -1, but does not include 1. So this function has a supremum, the supremum is 1, but it has no maximum. On the other hand, it does have both an infimum and a minimum, which is -1. To conclude, now that we have this language, there are two theorems we already know that we can write using these concepts. The first one is the consequence of the least upper bound principle. The least upper bound principle for sets says that if a set has an upper bound and is non-empty, it must have a least upper bound. The same thing is true for functions. If a function has an upper bound, is bounded above, then it must have a least upper bound, meaning it has a supremum. There is a corresponding theorem using lower bounds and infimum as well that you can write yourself. And the other theorem is one we already knew, is the extreme value theorem, but relates to these concepts as well, so I will add it here. The extreme value theorem says that if a function is defined on an interval that includes both endpoints and is continuous, then it must have a maximum and a minimum. So the first theorem tells me a situation in which a function is guaranteed to have a supremum, or similarly an infimum, and the second theorem tells me of a situation in which a function is guaranteed to have a maximum and a minimum.